Hello class, and congratulations, you've made it to week 8, the final week, in which we will be researching, learning, and writing about deep learning. Deep learning, as a part of machine learning in the last 4 years, has noticeably improved, enabling us to be able to communicate with different devices as we never have before. Nowadays, we can effectively interact as well as issue different commands by simply talking to our computers, our smartphones, or our cars. And for some of us, you can walk into a room and program different colored lights or music or heat based on wherever you are and whatever you want. Deep learning is really all around. In the last couple of years, major players such as Google, Microsoft, and Facebook have invested, researched, and developed many different projects that cause the rapid spread of artificial intelligence technology. We can see radical changes in voice usage in smartphones, so that now by utilizing Cortana or Siri, we can be sure that the person we are calling will absolutely be reached. In addition, Facebook's face recognition feature is so reliable that we don't need to search for usernames anymore while tagging. It's just done automatically. Furthermore, Facebook's algorithms are so powerful that by analyzing images, they'll be able to detect patterns and activities, and based off its analyses, predict or suggest your actions. So, if your Facebook pictures show you with your favorite pet, and many of your other pictures are showing people with the same kinds of pets, then its software will be able to learn and conclude that you like whatever pet, and it'll give you a link for a store where you can get your food for that specific animal. One of the major reasons why we can implement such algorithms is because of the abundance and availability of raw data generated by social network users. So how does it all work? How does the algorithm know that your favorite pet is a dog and that a dog is different from a cat or a wolf or a hamster? The general procedure for answering those questions is as follows. We have some algorithm that's given a handful of labeled examples, say 10 images of dogs with the label 1 of dog, and 10 images of other things with the label of 0, not dog. So those animals could be cats, birds, etc. The algorithm learns to identify images of dogs and, when fed a new image, hopes to produce the correct label. So 1 for yes, it's an image of a dog, and 0 for no, it's something else. This example is extremely general. So your data could be symptoms, and your labels could be illnesses. Or your data could be images of handwritten characters, and your labels could be the actual characters they represent. In those situations, you'll have multiple variables, such as illnesses or characters. In order to implement such algorithms, we'll have to start with a description of a perceptron, a basic neural network building block. Say we have n points in the plane, labeled 0 and 1. We're given a new point, and we want to guess its label. So this is akin to the dog and the not dog scenario from before. So how do we make a correct guess? Well, first we're going to pick a line that best separates the labeled data and use that as our classifier. In this case, each piece of input data would be represented as a vector x equals x1, x2, and our function would be something like 0 is not a dog if below the line, 1 is a dog if it goes above the line. To represent this mathematically, let our separator be defined by a vector of weights w and a vertical offset or bias of b. Then our function would combine the inputs and weights with a weighted sum transfer function. Second, the result of this transfer function would then be fed into an activation function to produce actual labeling. Once we clearly define the perceptron and we understand how to use it, we can go one step further and define a neural network. A neural network is really just a composition of perceptrons, connected in different ways and operating on different activation functions. Here's an example of feed-forward neural networks with its properties. The feed-forward neural network properties are an input, output, and one or more hidden layers. The figure above shows a network with a 3-unit input layer, a 4-unit hidden layer, and an output layer with 2 units. The terms units and neurons are interchangeable. Each unit is a single perceptron like the one described above. The units of the input layer serve as inputs for the units of the hidden layer, while the hidden layer units are inputs to the output layer. Each connection between two neurons has a weight, W, similar to the perceptron weights. Each unit of layer T is typically connected to every unit of the previous layer, T minus 1. although we could disconnect them by setting their weight to 0. To process input data, we clamp the input vector to the input layer, setting the values of the vector as outputs for each of the input units. In this particular case, the network can process a 3-dimensional input vector because of the 3 input units. For example, if your input vector is 7, 1, and 2, then you'd set the output of the top input unit to 7, the middle unit to 1, and so on. These values are then propagated forward to the hidden units using the weighted sum transfer function for each hidden unit, hence the term forward propagation, which in turn calculates their outputs, the activation function. The output layer calculates its outputs in the same way as the hidden layer. The result of the output layer is the output of the network. For more reading, you can look at this deep learning tutorial at https://deeplearning.net/tutorial/. Please take the time to read through this and to look over the examples so that you can get more information about deep learning as we're working through our last week of the course. I hope you've enjoyed learning about artificial intelligence, machine learning, and deep learning, and good luck in the rest of your academic career.